Hi everyone. So we are going to go ahead and begin chapter 10. Chapter 10 is about systems of equations and inequalities, and section 10-1 is about solving systems of linear equations. So there's two main ways that you have solved systems of linear equations in the past. One of them is by substitution. So for this example, this is on page 729. It's example number 4 in your book if you want to go back and reference that. But to solve by substitution, that's where you solve one of the equations for one of the variables, and then you can plug that into the other equation to solve. So for this example, I'm going to solve this top equation for y because there's no coefficient for y. It looks to me like that would be the easiest thing to solve for. So to do that, I would subtract 2x from both sides to get y equals negative 2x plus 5. And then I would put the negative 2x plus 5 in for the y in the second equation. So then this equation would become negative 4x plus 6 times negative 2x plus 5 equals 12. So now I can go ahead and solve that for x. Distribute the 6 to get negative 4x minus 12x plus 30 equals 12. Negative 4x minus 12x is negative 16x, and 12 minus 30 is negative 18. So x is going to be 18 over 16 or 9 over 8. Then I'll take that and plug it back into one of the original equations to solve for y. I like to use this equation right here that I already solved for y. So I'm going to take that equation, y equals negative 2. Now I know x is 9/8 plus 5. Negative 2 times 9/8 is negative 18/8. And then if I want to write 5 as a fraction with a denominator of 8, that would be 40 over 8. Negative 18/8 plus 40/8 is 22 over 8, or y equals 11 over 4. So that's solving using substitution. Another way is to solve by elimination. And elimination is where you want to add the two equations together so that one of the variables cancel out. So in this case, if I were to add these two equations together, 2x and negative x would be 1x, 3y plus y is 4y. So adding them together the way they are now would not cancel anything out. So in that case, I need to figure out what I can multiply by so that I can have, for example, this is a 2x. If this was a negative 2x, then when you add them together, then the x's would cancel. So what I can do is I can multiply this second equation by 2, because you can multiply any equation by anything you want as long as you do it to every single number in the equation. So this first equation would stay the same, 2x plus 3y equals 1. And then the second equation would be negative 2x plus 2y equals negative 6. So now when I add those together, the x's cancel. 3y and 2y is 5y. 1 minus 6 is negative 5. So y is negative 1. And then I can go ahead and plug that back into one of the original equations. I'm just going to use the top one. 2x plus 3 times negative 1 equals 1. So 2x minus 3 equals 1. 2x equals 4. And x is 2. So x is 2, y equals negative 1. Solved by elimination. Now, what you probably haven't seen before is a system of equations with 3 variables. So with this previous example, we were able to solve for both variables because there were two equations. When you have three variables, x, y, and z, you need three equations in order to solve for those three variables. So the way that this is done is you always have to start with elimination. So what I want to do is I want to combine two of the equations together to cancel out one of the variables. Then I'm going to multiply the last equation, I'm going to combine the last equation with one of the other two equations to cancel out the same variable. Okay, so looking at these, I'm going to cancel out the z's. See, if I look at these two equations right here, I can see that if I multiply the first equation by 2, this will be a negative 2z. And so when I add negative 2z to positive 2z, then they'll cancel out. So multiplying that top equation by 2, I get 2x plus 2y minus 2z equals negative 2. And then this middle equation is 4x minus 3y plus 2z equals 16. So now when I add those together, 2x and 4x is 6x. 2y minus 3y is negative y. The z's cancel, and that equals 14. So now I have an equation with just x and y in it. What I would need to do is make another equation with just x and y in it so I can solve those together. So going back to my original system, I didn't use this bottom equation yet, and I have to use it. So I'm going to combine this bottom equation, and I still have to cancel out the z's. So what I'm going to do is I'm going to combine the bottom equation with the middle equation. I'll multiply the middle equation by 3 and the bottom equation by 2. Because I want to cancel the z's out. So if I multiply the middle equation by 3, this will become a 6z. The bottom equation, when I multiply by 2, that becomes a negative 6z, and then the z's are going to cancel out. So the middle equation multiplied by 3 gives me 12x minus 9y plus 6z equals 16 times 3. I should be able to do that in my head if I'm going to use my calculator. It is 48. And then the bottom equation is going to be 4x minus 4y minus 6z equals 10. So now when I add these two equations together, the z's cancel. 12x and 4x is 16x. Negative 9 minus 4 is negative 13y equals 58. So now I have two equations with just x and y. So now I'm going to put those two together into the system. 6x minus y equals 14 and 16x minus 13y equals 58 and solve that system. So I can use either elimination or I can use substitution. I think what I'm going to do here is use substitution. I'm going to solve this top equation for y. So if I subtract 6x, I get negative y equals negative 6x plus 14, or y equals 6x minus 14. And I'll substitute that in for y into the equation 16x minus 13y equals 58. So when I do that, I get 16x minus 13 times, I want to make sure you can see it here, 13 times 6x minus 14 equals 58. So now I'll distribute the negative 13. So 16x, negative 13 times 6 is negative 78. Negative 13 times negative 14 is positive 182 equals 58. 16 x minus 78x is negative 62x. 58 minus 182 is negative 124. Divide by negative 62, and x equals 2. So now I've done most of the work. This is most of the work that's involved here. Once you get one variable, in this case the x, now I can find y. I can go back up and use this equation, y equals 6x minus 14. So y equals 6 times 2 minus 14. So y is going to be negative 2. And now I just need to find z. So now I'm going to take this x and this y that I've solved for and go back to my original system. I'm going to use this top equation here because it looks the simplest to me. So that equation is x plus y minus z equals negative 1. Now I know x is 2. I know y is negative 2. 2 minus 2 is 0. So negative z equals negative 1. And z equals 1. And now you've got your solution. X equals 2. Y equals negative 2. Z equals 1.